This is Chem 1215, experiment number 5. We will be determining Avogadro's number today. And to do this, we will be making use of the action of stearic acid to form a lipid monolayer on the surface of water. So, to get started here, these are the materials that we'll be using throughout the lab. We have hexanes. This is what our stearic acid is dissolved in. We have stearic acid dissolved in hexanes. This solution has a concentration of 1.93 times 10 to the negative 4 grams per milliliter. And we have a few pieces of equipment here. We have a petri dish. We'll be putting the water in to form the lipid layer on top of. We have a 10 milliliter graduated cylinder. We're going to be using this to calibrate our pipette. We have a ring stand and a clamp. This is all to hold our pipette. So in order to get accurate results here, we have to calibrate a past year pipette, because the volumes of this stearic acid solution that we're going to need to form that lipid monolayer is going to be very small. So we need to figure out how many drops is in a milliliter for this pipette. And to do that, normally when you use these past year pipettes, you use bulbs like this. That's fine for general use, but today we want some precision, so we're going to use a three-way valve bulb, and I'll explain how this works in a moment. But we're going to have this clamped into this clamp so that it's staying absolutely vertical, and we can do a nice controlled drop rate so we can get an accurate read on the number of drops for every 2 milliliters. So let's get started on that. So let's talk about this past year pipette and this bulb. So this is going to work just like any other bulb for a pipette. You're just going to push it on over the top of the pipette. You don't want to push too far because there's a valve in here and you can accidentally jam that with the end of the pipette, and that can sometimes knock that loose and then this stops working. So the way this pipette bulb works is I have 3 valves, and this top valve is to let all the air out of your bulb. It's marked with an A, and then this second valve is for suction. It lets fluid up into the pipette. Then this E valve is for eject. That's how we let the liquid that we are dispensing drip out of the pipette bulb. So I've brought over a little thing of hexane. We're going to be using, like I said, this clamp here to clamp us into this vertical position, and we'll be calibrating using this 10 milliliter graduated cylinder, and we're going to count how many drops of hexane it takes to get to 2 milliliters. And then we're going to fill this up again and repeat that till we get to 4 milliliters, and those two values should be within 5 drops of one another. That's another reason it's important to have a valve like this, where you can get more consistency out of how much you're letting out in each squeeze. So let's get started on this. I'm going to zoom out a bit so you can see a little bit better what I'm doing. First things first, I'm going to move this graduated cylinder out the way. We're going to let the air out of the bulb. Then I'm going to actually just bring my hexane to my pipette and begin to fill it up. And it might drip a little bit at first, that's fine. We're not counting these drips, so we'll just let them drip onto. I've got actually a piece of cardboard here, so it'll catch all of that. Let me get a paper towel. So I put a paper towel down just to protect my cardboard a bit. And if this continues dripping, a trick you can do is just very gently press down on the suction valve, just very gently, and you'll be able to draw up a void of air, and that should stop it from dripping. So now I'm going to move our paper towel out of the way and replace our graduated cylinder. Now we need this to drop consistently, and I only have two hands and I'm trying to film at the same time. So what I'm going to do is take our hose clamp, and I'm just going to use that to push down apply pressure to that eject valve, and then we'll be able to give all of our attention to the graduated cylinder as it drips. So let's zoom in on that. So we're zoomed in now, and what we can do to start our drop counting is just tighten this valve, this clamp a little bit. And now we have a steady drip rate that we can adjust just by tightening this a little bit. I'm not going to make you guys count this time because I've already actually done it. I've calibrated this pipette already. But you can see how much more convenient it is for you to be able to use a solution like this rather than have to rely on your finger being a consistent squeeze every time, having to multitask your attention on counting the drops and squeezing the pipette bulb. As it turns out, it takes about 211 drops to fill this to 2 milliliters. And the setup is pretty good because when we did the second run from 2 milliliters to 4 milliliters, we got the exact same number, the 211 drops. We'll go ahead and I think we'll just move on to the actual formation of the monolayer here so you guys can see how that works out.